Hello, this is the second step in setting up our console-based program that calculates the volume of the cylinder given the radius and the height. So what I've done is I've taken everything from step 1 here and I've copied it into a new file called step 2. And in this video we're going to address 5 things. We're going to use a built-in constant for pi. So I'm going to show you how to access what's called the math module. This is a really useful way of doing some more advanced mathematics. And it also kind of frames a larger idea around using functions that exist in other modules. We're going to round the output using the round function, which is contained in the standard library module. And that's something we've been using already quite a bit, but we're just going to kind of clear that up a bit. We're going to refine the output to make it look nicer. And what I mean by that is adding some more words, kind of to give some more feedback to the user, what's going on. And then we're going to position things on the console using escape codes. And then finally use those escape codes to do some special character work. Again, this is a minimal viable product. It's using the console. We're not going to take a long time to make this look super fancy. It's really just about getting an understanding of how to use these tools. All right, with that, let's dive in. So the first thing we're going to do is we're going to get rid of this and we're going to use a more accurate value of pi. So inside, there's something called the math module. So I just googled math module Python 3, and this is a module that contains a whole bunch of functions, and here they all are. And when we think of a function, we think of what it takes, what it does, and what it returns. So if we scroll down a little bit, we see we have the exponential function, the log function, there's a lot of them. It also contains some constants, and constants are just values that are defined that it stores for us to access. And it turns out if I just search through here, I'll find it at some point. So just search for pi. Somewhere here, there it is. Here are our constants. So we have a couple constants inside this module. So what I can do is I can access the pi value, and that's going to give me the most precise value of pi I can use in my program. So let's come back to here. And if I just type in the word, I could go here, I could say math.pi. So that means go inside the math module, take a look inside, think of it like a collection of functions and constants, and access that value pi. And if I save this and then try and run it, name, you see that I get an error. And the problem is that the math module isn't defined. And that's because in order to use this module, I have to import it. There are thousands of modules out there. And by default, they don't all get loaded. So what I do is I come to the top of my program and I write import math. And if I import the math module, now it knows that it has access to it. Think of it like a toolbox that I'm now going to bring along when I run my program as a bunch of different tools in it. So let's try this again. Paul 67, and it works. And what this does is, again, is it accesses the math module and accesses the constant pi, which is far more accurate than anything else. So now we've done that. So we've used the constant for pi in the math module. Now we want to use the round function to round the output because if we look at our output, this isn't really too useful. That's a lot of decimals. So if I go back out to the internet and I Google standard library Python 3, you get this documentation. And the standard library in Python, if I find it, let me just pull it. I'm going to go to the built-in functions. So these are all the built-in functions that are pre-existing. I know it's a function because it has brackets. And again, I can use any of them. I have ABS, which is absolute. I have all, any, ASCII. I don't know what a lot of these do, but I do know that I can figure it out if I think about what it takes, what it does, and what it returns. And if you look through here, you'll see there's a couple functions we've already been using. The print function and the input function. Somewhere in here. There it is. There's the int function that we use for casting. So all of these functions that we use regularly are in the standard library. So let's come back to here. And what I'm going to do is I'm going to take my volume and I'm going to apply the round function to it. Because it's in the standard library, I don't need to access the module specifically. Oh, I'm in the wrong program right now. There we go. So I'm going to say up here, volume equals round, and I'm going to round volume, and the round takes two parameters. It takes the value you want to round and the number of decimals. So I'm going to round this to 2 decimal places. So let's save this. Let's give this a go. Oops. And now I get 2 decimal places rounded. And so, again, you can round numbers using this round function, but the bigger idea is that you have access to the standard library, which has functions and constants that are commonly used as programming. Okay, so that's good now. This is done. So the next step is we want to refine the output to make it look nicer. Now, all I mean by this is basically give it a little bit more text, because the user might want that. So I'm going to pause it here, and I'm going to actually type some stuff in, and then I'm going to come back. So now I've made the output a little bit nicer. At the end, I've given, I've outputted their name to personalize it. I've actually outputted the radius and the height, and I've also given the volume. Now what I could do here is I could put the units in here if I wanted. Again, it isn't about getting it perfect here, but it's understanding how to use the print function to kind of communicate what you need to do. Likewise, I could do something at the front end to give a little bit more information. So let me just pause it here, and I'll do that. And so now I've added a little bit at the top saying the volume of the cylinder is, showing the formula, and I've given some context of what the program does. So let's run this and see what happens. So we get some information here. What is your name? Paul. 3, 4. Oh, that's gone off the screen, so let's pull that up a bit. There we go. So, hi Paul, given a cylinder width, radius 3, height 4, the volume is that. Again, looks okay. Now maybe I want to make this look a little bit nicer in the page. And so, what we're now going to do is we're going to use escape codes. Escape codes are ways of adding a special character inside a string to tell it to do something special. And there's 3 that we're going to talk about. We're going to talk about \n, which is new line, \t, which introduces a tab, and \u, which is a Unicode. And we're really going to do the Unicode in the last step. So let's start with this. Let's put some new lines and some tabs to make this look a little nicer. So I'm just going to pause it. So what I've done now is I've come in and I've said \n, \t. So you'll notice that these are inside the double quotes. And what it means is when it finds a backslash, it says, oh, don't print it, do something special, which is a new line. And then \, and that tabs it in. So what this does, it just makes it look a little bit nicer on the console. And let me pull that up, and we'll take a look what that looks like. So now notice I have some extra white space on the top. It's tabbed in nicely. What is your name? My name is Paul. Radius is 2, 5, and it prints out nicely down below. Again, escape codes are really useful because it can make it look a little nicer on the page. And let's actually, I want this to look a little nicer too. So I want this to be in line with all the other text here. So let's come back into my program. And I can use them inside any string. So I'm going to say \n to make a new line. So you get a little space and \t, \n, \t, and \n, \t. And let's take a look what happens when I do that. Actually, let's clear it. So now notice my input is in line. Again, it's not about getting this perfect right now. It's about playing around with these special escape codes and understanding what they do. Okay, so now we've used some escape codes to clean this up. So that's done. So now the last thing I want to do is I want to set up some special characters. And so what I mean by that is, if we take a look at our program again, what's come out, probably a lot nicer instead of radius if we could do something like radius squared or height squared. And it might also be nice if I can put in an actual multiplication symbol. So to do this, I'm going to use what's called a Unicode. So a Unicode is a special code which is in hexadecimal often, and it allows the program to print a special character. So if I come up and I do a Google search for Unicode characters, you get all your characters here, and every character on your keyboard has a Unicode associated with it. So there's my power of 2. And we see the escape sequence is \u for Unicode 00B2. So if I copy this and I come back to my program, for example here, I want to say radius squared. So if I put \u for Unicode, and then I put the hexadecimal code there, it will do something special. So if I save this, let's run this, and see how I get this nice squared now? That's a nice way to actually kind of introduce, make your program look a little nicer. It turns out I can also use, there's a escape code for multiplication as well, which is nice. So, and there's one for pi. And I happen to know those Unicodes already because I've looked them up. So I'm just going to go back into my program here, and I'm going to take out pi, and I'm going to say \u for Unicode, and 03C0 is the Unicode for pi, \u for Unicode, 00D7 is the Unicode for multiplication. 00D7. It doesn't matter if it's capital or lowercase. So let's put the D there. Let's give this a save. Let's take a look what happens. Clear. And now I get this nice pi times radius squared. I can add some space in there to make it look a little nicer. Let's just crash this. So I'm going to actually put a space between those. And let's just go back and look again. Oh, I can scroll up a little bit. I want to put a space after the squared, I think. So let's come back here. There's that space. And I can do the same thing down here. Actually, that's the only place I need it because this is not printing. So let's save this. Let's give this a run. And I get a little bit nicer look. So that's a nice way to use Unicode to actually make it look better in your program. I hope this video helped. In our next stage, we're going to do some error checking and make this a little bit more resilient from a user experience. Have a great day. Take care.